Good morning, class, or afternoon, or I know some of you work at night, so I'll say good evening. Today we're going to talk about statistical measures. Okay. At the end of this lesson, you will be able to one recognize a statistical question versus a non-statistical question, and two, you will be able to display and interpret data on number lines and plots. Specifically, we will be making dot plots today. Statistical versus non-statistical questions. Statistical questions will have multiple answers. Non-statistical questions only have one answer. Let's go over a couple questions and see if you can tell me if this is statistical or non-statistical. You can talk to yourselves, but I can call on you if I feel like it. How many letters are in the alphabet there? I'm hoping you said that is a non-statistical question because there are only 26 letters in the alphabet. Yes, Milo, I know there's more or less numbers in the Greek alphabet. Well, we are talking about the American alphabet. Thank you, Milo. How many Hallmark movies did you watch this year? Yes, Boo Boo, 26 is a good answer. Yeah, I got 1.5. Mick Jagger, yeah, he got 0. So this is a statistical question because there are multiple answers. How many letters are in your last names? That's correct there, Davis. I can always count on you. That is a statistical question because in your last names you have lots of different answers. Jackson, you have 7. Woodman, you have 7. Elrod, though, you only have 5. So we have multiple answers. So that is a statistical question as well. How many centimeters are in 1 meter? Well, the correct answer would be 100, and there is only one answer. So that is a non-statistical question. How many pennies are in a quarter? 25. Good job there, Cody. We are getting a hang of this. What's your favorite sport? Statistical question. That is correct because there are many different answers. Do you prefer regular Skittles or sour Skittles? One more time, I think we would get 2 different answers. I prefer sour Skittles myself, being the Skittle connoisseur that I am. And I'm sure so many people would say normal Skittles. So we would get 2 different answers. So that would be a statistical question. Who's your favorite music group or singer? Well, I know I would say Kiss. But you got Mick Jagger over there saying he likes Katy Perry. You got Griswold saying Taylor Swift. You got, I heard Elrod yell out Pink. So there's multiple different answers. So that's what I wanted you to get out of it. Statistical questions have many different answers. Non-statistical questions have only one answer. So let's say we conduct a science experiment and we ask ourselves, what is the weight of a house mouse? Is this a statistical question? Well, first, I hope you don't have house mice, but if you do, we could weigh 20 house mice and we could very easily come up with 20 different answers. So yes, it would be a boo-boo statistical question. You are correct. Okay, so let's say we weigh these 20 house mice and we put their weights in grams in a table, as you see I did on the right. No, over there. You got to look over there. Oh, other way. There you go. Next thing we do, we're going to make a dot plot. So stay with me here. This is going to get fun. Okay, so now we're going to make a dot plot. First thing when you make the dot plot, you have to draw yourself a number line. Yeah, I got a new toy, so I'm trying this out. So hopefully it works. The document camera. Okay, so you make your number line. And you always start off with the smallest number that you got. If you look in our table over to the right, you'll see that 18 is the smallest number we have. And I believe that 28 is the largest number that we have. So, go ahead and make your dot, continue making your number in your lines. I'm done. What took you so long? Okay, so next thing you do, go ahead and you start to make dots above your numbers. Go ahead and start with the first number. First number is 20. Next number is 18 on our table. Next number is 28. Next number is 20. Next number is 19. And you go ahead and do this. Complete it. I'm going to give you a couple of seconds to complete your chart. Go ahead and press pause. Okay, I finished making my dots. I hope you finished making yours. So I'm going to go ahead and get rid of my table. I no longer need that table. So now you're just looking at my dot plot. Now looking at your dot plot, we can ask ourselves several questions. Or we need to be able to identify several questions. Okay, first question would be... Okay, first question is, are there any outliers? Outliers means, are there any oddballs? Ones that are really far out there. Okay? You might say that these 27 and 28, these three mice down here, would be considered outliers. Because the majority of this data sits over to your left side of the graph, or the dot plot. Okay, are there any peaks? Right here. This is what we call a peak. Yeah, look at that handwriting. Okay, next thing you have to identify is a cluster. Okay, let me change the color on this because I can do that. I'm that cool. And this is a cluster. Okay. A cluster is a group. They're like all clustered together. That makes sense. And the other thing that we're going to identify is the gap. Okay. One more time. I'll change the color just to distinguish. Right here between, I'd say between 24 and 27 would be our gap. Okay. So three things you have to be able to identify are clusters, peaks, and gaps. Well, fourth would be the outliers, if there are any. So I'm going to give you another problem that you can work on by yourself. Okay, this question would be, what are the weights of the average sixth grade student in our class? As you can see on our graph, on our table to the right, I put down 20 different weights to show you, okay? So, who remembers the first thing we have to do? Okay, good. Good there, Schumacher. We have to make a dot plot. And we have to start off with a number line. We always start off with the smallest number, which would be, I'm seeing 83 as our smallest number. And our largest number, which would be, I believe, 101. Okay, so what do we do next? Yes, you fill in the numbers, fill in the rest of the number line, and then we make our dots. So go ahead and press pause, and I want you to go ahead and fill in your dot plot. Great job. Now that we're done with that, I am going to get rid of our table just for a second so you can see it. Now we are ready to put in our dots. Go ahead and press pause, put in your dots, and we'll see if your dot plot looks like mine when you get done. Okay, if you're done with your dot plot, it should look something like this. Okay, once again, you got to identify a couple things. Down here, you might say there's some outliers. The next thing I want you to identify is your peak. Remember, peak is the highest point. Yes, right here. This is our peak. Then we have to identify clusters. Oh, we got a pretty good cluster right there. I would say that's our cluster. And do we have any gaps? Now, I say we have two gaps. We have one that goes right here. And then we have one that goes right here. So you can have more than one gap. but you can only have like one peak, or I guess you could have a couple of different peaks, right? But and then you have a cluster, what's all grouped together. Many of you are wondering why did I show a picture of a candy bar? Because I want to see how many people are actually watching this video. So in your homework tonight, this is one of the questions. You're welcome for throwing in an easy one right there. Thanks for watching the video though. Okay, so the next thing we're going to do is we already have a dot plot right here. This is a vertical dot plot, and now you need to interpret what the graph. So we recorded the high temperature every day while at summer camp in August. Then we created a vertical dot plot. How many weeks were you at summer camp? Well, if you look at this, we recorded a high temperature every day, so we should count up the dots. And if we counted up the dots, you would come up with 28. How many days are in a week? Very good, 7. So if you do 28 divided by 7, how many weeks were you at summer camp? That's correct. That would be 4. How do we collect this data? Very easily, we went out and looked at a thermometer. That's how we collected this data. What are the units in this data? Remember I said it's important to have labels? Well, let's look. 87, 86, 85, 84. What do you think that's talking about? That's right. Degrees Fahrenheit would be our unit. Okay? And when you look at a dot plot, you should be able to ask a statistical question. Okay? Can you think of a statistical question right now with this dot plot? Go ahead and press pause and come up with one statistical question. If you said what degree temperature was recorded the most, you would be wrong. That would be a non-statistical question because there's only one answer. That would have been 86 degrees. An example of a statistical question would be, what did you like doing most when the temperature reached above 86 degrees? I'm sure some of you said swimming. Some of you would say playing basketball. There's probably a few of you that would like to do some underwater basket weaving. But, as you can see, there are many different answers to that, so that would be a statistical question. What do you like to do when the temperature is above 86 degrees? Here's another example for you. This dot plot shows the height of 6th grade students in a gym class. How many students are in the class? How can you collect these data? How do you collect this data? What are the units? And I want you to write one statistical question. So go ahead and press pause. Go ahead and answer those questions. And I'll come back and we'll figure out what the answers are. I appreciate you answering those questions. How many students are in this class? Well, you would go ahead and count the balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I came up with 24 students in this class. Okay, next thing you do, how do you collect this data? Well, very simple. You can measure yourselves. And what is our units? That would be height in inches. Right, a statistical question. If you said, what is the average height of a student? You would be wrong because you could actually collect all that data and you would come up with only one answer. If you asked, can the students who are 62 inches touch the net? That would be a statistical question because you would have several answers. I'm sure you would have Jagger saying, yes, he can touch the net. Well, if my 6th grade self, I'd be like, no, I can't touch that. Yeah, give me a couple building blocks and I might be able to touch that. But no, that would be a statistical question because I'm sure that some students can touch the net and some students cannot touch the net. Here's our second candy bar that we asked you to find. Okay? I want to say thank you for watching the video one more time. That is the end of our presentation, so thank you.